The title of this note is Matrix Algebra. Be sure that you've put your name, date, and class period in the top right-hand corner. And the goal of this lesson is to show you how you can use matrix equations to solve a system of linear equations. Okay, so you can solve a system of linear equations using what are called matrix equations. And basically what's going to happen is you are going to put a bunch of matrices into your calculator, and your calculator is going to spit out the answer. Now, why did I make you learn how to do Gaussian by hand and Gauss-Jordan by hand? Well, how does the calculator spit out the answer? Basically what's happening is the calculator is doing Gauss-Jordan elimination in the background, and then it's just popping out an answer. So if you think about some potential jobs, some things that you could do in the future, using a calculator is not that impressive. But somebody had to know how to do Gaussian elimination in order to program the calculator. So that computer programmer is someone who's making a lot more money than I am. All right, so here we have a chart. Look over on the left. You have a system of linear equations. And we're going to, instead of using an augmented matrix, we're going to use two separate matrices. We're going to use one matrix for the coefficients. It's going to be called the coefficient matrix, and we're always going to call that one A. And then X is going to represent all of our variables, and B is going to represent all of our constants, our numbers without a variable. So B is our constant matrix. If you see here, we can then rewrite the system as a matrix equation, where we have matrix A times matrix X equals matrix B. So that's going to be our matrix equation. Okay, so if you have a unique solution, the solution is going to be in matrix X, and it's going to be represented by A inverse B. And this will technically have a matrix somewhere around it. So matrix X equals the inverse of matrix A times the matrix of B. So here's what you're going to do. You are going to put matrix A into your calculator. I would like you to actually do this right now. Put matrix A into your calculator. So as a reminder, you are hitting second matrix. It's the X inverse button. It's about the fourth down all the way on the left. And you're going to scroll over to the edit menu on the right. And it says choice number 1 is A. You're going to hit on A. And you're going to make sure it's a 3 by 3 because this particular matrix has 3 columns and 3 rows. And then you're going to type in all of those values. Once you've done that, you're going to do the same sequence. Second matrix. And this time go back to edit. And down to B. And B will be a 3 by 1 matrix. B will be a 3 by 1 matrix, and you'll input those 3 values. Then you're going to go back to your home screen. That's second quit. And you're going to do second matrix again, but this time you're going to stay in the name column. And you're going to hit enter, and that'll bring matrix A onto your home screen. You'll then press the inverse button. It's the X-1 button, same button you're using for the matrices, but without the second button first. And then, again, second matrix, and this time you're going to name matrix B. Then you can press enter. Once you see this on your home screen, you can press enter, and it'll spit out a matrix. And the answers are in order. X will be the first answer, Y will be the second answer, Z will be the third answer. So try this one. Make sure that you're getting the solution to this one. Okay, so the key here, don't write this stuff down. The key here is that this only works if your system is consistent and independent. So if you have a scenario where you have no solution or infinitely many solutions, you're going to run into a problem. And the problem is that not every matrix has an inverse. And an inverse just means that when you multiply them together, you get back to 1. So if you think about the number 3, the inverse of the number 3 is 1/3, because 3 times 1/3 is 1. What does 1 look like in a matrix? It's the identity. It's your RREF. So A and A inverse are two matrices that when we multiply them, get us back to what's called the identity matrix, and it's represented by a capital I. If A does not have an inverse, you will see something on your screen that says error, non-singular. When this happens, you're going to say that matrix A has no inverse. Has no inverse. And therefore, your system does not have a unique solution. Now, unfortunately, you don't know if it has no solution or infinitely many solutions. All you know is that it doesn't have one solution. It has infinitely many or no solutions. If that's the scenario, you cannot use matrix equations to solve the system. That is going to be a question on your test. You'll have a system, and the question is, can you use matrix algebra to solve the system? So you are going to put it into the matrices, and you're going to check. If you get an answer, then yes, it was possible. If you don't get an answer, no, it's not possible. And to get full credit, you would have to say why. It's not possible because A has no inverse. That's all for our matrices notes. Go ahead and draw your line for your summary.